I'd like to start by showing you some Java code for a TCP server and client, much like we looked at a UDP server and client. So here I have again imported some useful Java libraries, and my main function has the server port 5679 this time. Unlike UDP, where we created a socket that we would use to talk to clients, in the case of a TCP server, we start with a server socket. It's not the same thing as a regular socket because we won't send or receive data through this socket. This socket is to receive new connections. So the server creates this server socket at a particular port number, that is the one that clients will know to connect to. And then we're going to go into a loop, not receiving individual messages, but receiving individual connections. So the server will wait until some client connects by calling the accept method on the listener object. And this will return a socket that corresponds to a connection. This is a socket similar to the UDP one where we could send or receive data, but the way that we do it with TCP is we convert the socket's endpoints to a stream. So we get an input stream as a general Java place that we can read bytes from, and we get an output stream as a general place we can send output bytes to, and when we read and write on those streams, it'll correspond to receiving and sending messages over the TCP connection. I'm going to create a 5-byte buffer here, and my server is just going to read up to 5 bytes from a client this time, reading them directly from that socket, but from the input stream that we got from the socket. It prints out where it heard from. Again, we can find out who connected to us as a TCP server, and then shows the data. And then it's going to, in this case, echo back the data that it got. So it'll take the same buffer where we read the input and send it back out. One more time, notice there's nothing about a packet here in this description. Since it's stream-oriented, we talk about reading and writing on streams. When we're done, though, we do close the socket, and that has the effect of closing both of those streams and ending the connection with the client. So let's start our server running. And it's listening at 5679. Over here we have the client side. Client knows that it needs to talk to 5679 on localhost. And the client, when it creates a socket, it does connect directly to the server. So that's why we have the server's address and port number, and what we get back is the connection to the server. As on the server side, we take that socket and get input and output streams from it, and now we can read and write on those streams. So the client, instead of waiting for the server to say something, the server is waiting for us based on the one that we just looked at. And so the client starts by writing bytes 10, 20, and 30, then reading back from the connection because the server is supposed to echo those back to us. And for every byte that we got back, the client's going to print what it saw, hopefully the same bytes that it sent if our server is really echoing things. And then the client also closes the connection, ending its connection to the server. So if we run the client, we see 10, 20, 30. That was actually data sent to the server and then sent back to us. And if we go look over at the server, we see that it did indeed hear from a connection on the same machine, and it got bytes 10, 20, and 30.